I have the opportunity to talk about the first topic, introduction into inkjet printing for research and development, and then specifically for the research part. So my name is Dennis Kuppens. I've been working for the PiXDRO department for about 10 years already, so I know quite a bit about the whole inkjet. I'm product manager of the research and development inkjet tools that we have developed over the years. So I hopefully can tell you something about inkjet. And because many of our viewers are not expert or don't even know anything about inkjet, I really want to keep it at a very high level for everyone to understand what inkjet is all about, and especially what we as SUS do in the inkjet business. So let's start off with the first basic question. What is inkjet printing basically? Well, let's have a look at what we actually need to get started into inkjet. Of course, we first need a digital image. We need a photo we want to print out, or we could use a technical drawing. As long as it's digital, it can be used. Of course, you need some kind of ink, and in most cases, people at home have an inkjet printer and there will be some colors in there, but in our case, it does not necessarily have to be a color, but it can be any material. And of course, you need to print something onto, and that can be a substrate of, for example, paper if you want to print out a photo, or a printed circuit board if you want to go into a little bit more technical. Beside this, of course, we also need the inkjet printer itself. This is the SUS LP50 inkjet printer, which has been developed specifically for the research and development phase. We will demonstrate that later on in the presentation via a video, so please stay with us until the end of this presentation. But let's have a closer look at the core component or the core feature of an inkjet printer. What does an inkjet printer basically do? Well, in the shortest sentence I could find, it basically converts the pixels of the digital image to inkjet droplets. That is the main purpose of what an inkjet printer does. So if you zoom in a little bit more into the core components of this inkjet printer, then the printhead is very important, because this is the actual component that will jet the droplets. So let's have a look at a schematic. Above you see the printhead, and below you see a substrate, and you notice that the printhead floats a distance over the substrate. So now let's have a look at those ink droplets. Here you see a movie of the printhead jetting droplets of ink onto the substrate. This is the basic principle of inkjet. And if we then go look at the result, then obviously we get the printed picture, or we get, in this case, a PCB board which has been printed with a solder mask layer. So if we stick to the technology a little bit longer, then let's have a look how a printhead then actually converts this image to droplets. So on the left you see at the bottom a substrate, the blue square is a printhead, and above there are some white and black pixels. These pixels come from an image. So it's very magnified and simplified, where a printhead will scan, or the printer will scan the digital image and then tell the printhead when to jet a droplet or not. So let's have a look at an animation. the printhead will move over these pixels, and then you will see when a droplet is being jetted or not. So now it's white pixel, black pixel, black pixel, white pixel, no drop, black pixel, drop. This is only one nozzle printing one droplet. As you seen before, a printhead can jet with much more droplets at the same time, where each nozzle is printing a line of pixels. So they can be addressed individually. But printheads have more nozzles than only 5. So here we have like 10, but most printheads have hundreds of nozzles or even thousands of nozzles. So that's the beauty of Inkjet. It's really scalable. So a single printhead can already have thousands of nozzles ejecting droplets. But if you combine printheads, so add printheads, then you can have even more nozzles jetting droplets. So up to 100,000 of nozzles, and they can all jet up to 100 kilohertz. But now take a step back. What kind of printing applications are there in the world? Well, everyone knows about the packaging, the publication, and the decorative business. I've provided here some examples. So if you look in the supermarket, every package of almost all food has been printed in one way or another. Of course, there are a lot of magazines going around that have to be printed. Textiles is quite a big market. So in this case, the European flag. But also ceramic tiles are being inkjet printed today. So if you redecorated your bathroom lately, chances are that you have an inkjet printed ceramic tile in your bathroom. So it's all over us, around us. A second big application field I call the 3D structural printing. It's quite emerged in the last years, and almost everything can be printed, from gears, gadgets, medical applications, and even houses are being 3D printed. This everyone knows. What probably not everyone knows is that there is an application field we call functional printing. And this functional printing, it's called functional printing because we print functional material. It does something. So the material lights up, it isolates something, it codes something, it helps in augmented reality to get the right reflection, for example. Even conductive or dielectric inks can be used. We as SUS, we believe that functional printing is the next revolution in printing. So we will focus with our tools and our knowledge and our process development in these topics. But functional printing is something different than the other application columns that I showed you before. So let's compare them. So in the decorative and 3D printing application field, you have a sequence of process steps. Let's have a look at those. So you have all kinds of process steps. Then you have a printing step, finishing step, and then you are done. So at the end, printing is one of the last steps. And what has been printed is part of the end product. So the color ink is part of the magazine. If you 3D print something, it is directly the end product. However, for functional printing, this might be slightly different. Let's have a look at the sequence of a functional sequence, process sequence. Here you see process steps, and printing is already in the beginning, and again somewhere in the middle, and perhaps not near the end. So functional printing can be done anywhere in the process, and what has been printed is not necessarily part of the end product. And this is very important to understand the rest of this presentation, but also the presentations of the people that will speak after me. So please have a look at this. To help understand this better, I have some examples. For example, inkjet printing can be used as a masking process step, where you first print something on a substrate. So the orange part has been printed. The next step will be a chemical step outside of the inkjet printer, where the substrate is being etched. Obviously, where the mask was, the etching will not take place. And afterwards, the ink can be removed. Depending on the ink, it can be very simple, it can be a little bit more difficult. But in this case, we have a nice example of inkjet being used in functional printing, where the ink is not part of the actual end product. It's just a means of creating the device or the product. Another example where inkjet is part of the end product, but not at the very last process steps, is, for example, a flexible barrier for OLED encapsulation. So the encapsulation obviously is part of the screen, but is not necessarily done at the end of creating this OLED screen device. Another example is to provide some protection, for example, on a type of wafer. And inkjet, because it's digital, can follow the edge of that specific wafer. It can be a round wafer, square wafer, it doesn't matter. And of course, this protection is perhaps needed for some process step, but in the end product, it will not be part of it. Then have a look at printing technologies, because we are talking about inkjet technology, but is it the only printing technology? Well, of course not. So I've divided the technologies in analog and digital printing. There's also something in between. They call that hybrid printing, where the analog process or the technology uses some steps in the digital process, but eventually in the end the process is still analog. So in case of screen printing, as you see in the picture on the left, the screen design probably comes out of a computer, but eventually the ink has to go by an analog way through the screen onto the substrate. So let's compare or let's view at some analog processes. There are many. Here's a summarization of some. And the same goes for digital printing. So inkjet is at the top, but there are other digital ways of printing. So if we have so many different technologies, then why did we as SUS choose inkjet as a technology to focus on? Or you could read this as, why should you choose SUS inkjet technology? It's digital. So being digital enables new opportunities and solving issues impossible to solve with traditional techniques. We come to that later on the topic. It's scalable. So you already have seen we can scale it to thousands, tens of hundreds of thousands of nozzles jetting at a high frequency, where each individual pixel is being converted into a droplet or not. So that's why PiXDRO and now SUS has been developing these tools for many years already, and we provide equipment from the research phase to the development phase, to the scale-up phase, and the mass production phase. And here are some examples of those tools. And another thing, it's very important to understand that of all the technologies you have seen in the previous slide, the digital technologies, that is, Inkjet is the only one that is so scalable, but is also so mature to be used in a high volume production. So the components like printheads, which are key and core components, and some inks being developed by companies in the world are so mature and have been proven for many, many years already in this industry, in the graphics printing industry, that you can really rely on that for high volume production. So now that we know this, I would like to ask you, where could you use Inkjet? Perhaps this has opened up a new idea, new vision on this technology for you. And I've put here some questions that you can ask yourself if that applies to you. So, do you need individual modifications? Is not every substrate the same as the previous one or the next one? Are you facing stricter environmental pollution regulations, for example? Or do you find it difficult to track the substrates during production? Perhaps you need a contactless method to apply material. You need a variable thickness of applying material. You really want to speed up the startup time, for example, when you have a new design, because you have small runs of batches that you do. Perhaps you just need to improve the yield. Who doesn't want to do that? And perhaps consumables are expensive. These are just some questions you could ask yourself, not necessarily all the questions, of course, but that's why I want to ask you, what is your challenge you're looking for? Perhaps I'll give you some answers to those questions by telling you about the main advantages of digital inkjet printing. Well, it's cost effective. It has virtually zero waste. You have probably less process steps, because if you add ink or add material where you need it, you do not have to remove it afterwards, for example. It's fast. So it's digital. If the images are available, every single substrate can be different, because the printer instantly loads a new image and can print a complete different design. Individual customization might be very important. So perhaps in the whole process that you're looking for is that there are deviations in the substrate. And what you could do is implement countermeasures for that using Inkjet, because we can change the digital image just before we want to start printing. We can change it and adapt it to perhaps a failure or a misalignment in the previous process step. And this could still provide you a working device in the end. Or perhaps serialization. So because it's a printing technology, we can add numbers, we can add QR codes wherever you want on the substrate. More QR codes, one QR code, it really doesn't matter. And of course, it's a very versatile technology. So it's a non-contact technology. We've seen that before in this presentation. And it can be used for different applications and different processes. It's not necessarily that inkjet technology can be used only for, say, conductive lines. It can be used in another stage in the whole production with a dielectric ink, for example. And because it's digital, You can go over in multiple layers over a substrate with different images, so you can have different thickness of material being applied where you want on a substrate. And a printhead is capable of supporting many different functional inks. But as always, Inkjet is not the solution to everything. So let's have a look what to consider when you want to use Inkjet. First of all, we have a droplet. We have seen that in the video already. We have droplets that have a certain size, and the size of a droplet is being determined mostly by the printhead type. So if we take a look at quite a typical droplet of a fairly small type of printhead, then the printhead itself is not small, but the droplet of that type of printhead is quite small, and it's 4 picoliter. Look at the diameter of such a droplet. Well, it's about 20 micrometers. Features much smaller than 20 micrometers will be a challenge, especially if you consider that this droplet, it's like a liquid. When it hits the substrate, it will flow out even more. There are many ways to control the flow of this droplet, and we will see that later on. Like I said, a printhead is quite specific for a specific droplet size, and in our tools from SUS, we support, I think, over 20 different printhead types, ranging from 2.4 picoliters to 80 picoliter printheads. The 2.4 is interesting for very small features. The 80 picoliters is interesting for larger surfaces to more quickly build up the layer that you want. We also have to look at the inked properties, because in the end, the ink has to pass through a printhead. It has to be jettable. So the material has to be within the range of the viscosity from about 2 to 30 centipoise. Well, for people who don't know what that actually means, well, it's about water to warm olive oil. Then you have probably an idea what the viscosity might be. Surface tension, 20 to 40 dynes per centimeter. This you really have to look up in the data sheet or have a measurement tool to measure that. Particle size, if we are talking about conductive ink, it's often built from silver nanoparticles. The rule of thumb for these particles is about 1/20th of a nozzle diameter. So if you look at the droplet above, so the 4 picoliter droplet, that's a diameter of 20 micron. The nozzle diameter of the printhead is also 20 micrometers. So the particle size has to be smaller than 1 micrometer. And the temperature, a printhead is an electronic device, so temperatures have to be within about 2200 degrees Celsius. But printheads, like I said earlier, are developed for many years, are very mature, and can support a wide range of chemicals. Solvents, acidic, all kinds of material can be inkjetted as long as the ink properties are within the boundaries of the numbers above. When we put this in perspective to the other technologies that we have seen before, that we can show here. So Inkjet can provide you a minimum feature size of about 20 micron, but that's already quite a hard limit. If you want to go smaller, then you really have to look into other technologies. However, Inkjet can go bigger, much bigger. If you want to print square meters, that's not a problem. So we're only looking here in this graph at the minimum feature size. And depending on the printhead, depending on the ink, depending on the substrate, depending on the environment, the minimum lies somewhere between 20 and 100 micrometers. However, like I said earlier, because it's Inkjet, it's digital, you can have multiple layers. So you can really build up a certain height of layer that you want. If you want a really thin layer, you can thin down the material and add solvents, or you can build up the material to 100 micrometers or even higher. But this is all great. Then why is R&D, especially research, still needed? Well, it's a very broad application field. There are enormous number of applications possible with technology, yet not so many turnkey solutions have been developed that you can just use it and buy it. So there's a lot of research going on in all kinds of functional fields, and if we have a look at the active Inkjet R&D programs that we are involved with by supplying the R&D LP50 inkjet printer, then this is just some of the applications, some of the businesses that our inkjet printers are being used in. So it's not only semiconductor, it's also the OLED business. Solid state battery is becoming increasingly interested in inkjet lately. Photovoltaics already for many years, and especially now with the new perovskite inks that are really easy to inkjet. Biomedical, security, and many more. But you can have a look yourself at over 100 research papers that have been published in only the last few years, where the PiXDRO SUS LP50 inkjet printer has been used for that research. You can have a look yourself at the sites where these publications are available. Now, how can SUS then help you start your inkjet development? If you're interested in this technology and you have seen the opportunities and you have seen the boundaries, well, I prepared a video showing off the LP50 inkjet printer. Then you get a sense of what it can do. It's only a short video showing some of the highlights. So the system, LP50 inkjet printer, comes with a PC, our in-house developed software. The printer itself is a desktop printer, and it comes with a utility station providing all the pneumatics. So the printer only uses power and exhaust. All the utilities are in the printer itself. When we open it, you can see the printhead installed in there, and the ink header tank, a small ink header tank, is right above it. And the printhead can rotate. The substrate moves under the printhead. The system comes with a maintenance station installed to wipe off the printhead and kept the printhead overnight. It also comes with a drop watch system to look at the droplets you've seen in the movie on the first slide. This is a maintenance action performing to wipe the printhead, to make it clean, to start printing the next print. So the cloth has been advanced to have a fresh new part, and this is showing off how the printer moves to actually start printing. The printhead is part of a printhead assembly and printhead configuration that comes with a printhead assembly, a printhead driver box, and a capping station. So when we look at the printhead assembly, you can see that the printhead is installed in the center of it. And once this printhead has been calibrated in position, the printhead assembly can be inserted into the printer very accurately. I'm showing you now a UV lamp, and that is for extra control of the flow. This is a printhead ink tank, and that connects to the printhead. A very unique feature of the LP50 printer is that you can exchange to a completely different printhead type, even of a different brand, without even turning it off. So now I'm going to show you how this is going to work. And the printhead that is installed now is typically used in the research phase. So it doesn't have many nozzles, but it can be used to develop the inks, to improve the inks. So we take out the whole printhead assembly, including the printhead and the ink. And in this case, we also have to exchange the printhead driver electronics, because that one is specifically for a specific printhead type. And now we move to a different type of printhead, which is more usable for the development phase, where the inks are already developed or quite stable. We only have to insert that, tell the software that the new printhead assembly and the printhead is installed. Then we need to connect the meniscus pressure tube. And the printhead assembly had been calibrated before, so the software knows what type of printhead is in there, what printhead assembly, so it's fully calibrated. So now we only need to connect the electronics drivers to the rest of the system, and we're good to go to start printing. Well, this is an example of the printer printing and pinning the ink at the same time. Now we're going to have a look at how the software views the droplets that are being jetted. And here you see that the software has many parameters. The software is specifically developed for research and development. So every available parameter is also available to the operator. Here we see that the software scans all nozzles, stores that in one measurement file, and that file can be recalled at a later moment, and have a look at what the characteristics of the droplets have been of all the nozzles. So the number of nozzles is at the bottom of the image, and when we select one droplet, we can see the speed, the volume, the position, and the angle of the jetted droplet. And this can really help to optimize the print process. So a last feature I would like to show you is the print simulator. So even before printing, you can already simulate what's going to be printed where, and when we zoom in, we can really zoom into each individual nozzle, and to show what droplet will be printed by what nozzle. We come now to almost the end of the presentation for me. So in conclusion, I would say go for inkjet printing if you're interested in this technique. Doesn't matter in what phase your program or your research program is at this moment. If you want to have more information, please go to the website lp50.sus.com. And then I want to really thank you for watching and listening to this presentation.